Welcome back, friends. Let us begin our next module, which is on non-motorized transportation. We have looked at so far at the 5 basic steps of planning for non-motorized transportation. Now, we will get into the details of bicycles and pedestrians one by one. In this lecture, we will be looking at the characteristics of pedestrians and bicycles and get into the traffic flow equations and the factors that affect pedestrian speed. Now, when we are going to plan or design any facility, you have to understand who you are designing it for. So, at a broad level, pedestrians are defined as any person on foot, right? Anybody who is walking is a pedestrian. However, while planning for pedestrians, we also plan for people who walk, not only walk, sit or stand in public spaces, uses a walking stick, crutches or a wheelchair. We look at different types of people, old or young, workers or residents, as well as shoppers who are shopping in the market area along the streets, right. This is a definition given in IRC codes. So, it kind of encompasses everybody who is on foot, who is standing, who is running, playing around, a mother with a toddler in the stroller, a person on a wheelchair that is being pushed by another person. So, when we are looking at designing any pedestrian facility, we are looking at each and every one of them. And also remember, every motorist is a pedestrian in some part of the trip, right. Even if you are driving a car, you have to get to your car. So, while you are getting or accessing your car, you are most likely walking to your car. So, facilities such as footpaths or sidewalks that lead up to a parking facility, they have to be designed in mind, keeping in mind the accessibility needs of the motorized people as well. Now, when we look at the space requirements for each pedestrian, they are usually determined by the ellipse that our body forms. If you look at our body from the top view of the body, then we will see our head, which is in this black circle, and the shoulders, the gray elliptical, as well as the buffer area that is needed for free movement of your arms, right. When you walk, your arms swing. So, there is some free buffer area that is needed by each and every person in order to walk freely. So, this is your body width and this is your body depth. So, these are the basic dimensions, these are the basic elements of the body which has to be taken into consideration while you design for pedestrians, while you design any facility for pedestrians. Now, there are different values that are used based on the average person in that country, right. Some of the countries may have average height and width of the body different, versus some other countries may have heights and width different. So, in the highway capacity manual that was developed in the United States, they usually use the value of 0.6 meters for the body width and 0.5 meters for the body depth. Whereas, the Indo highway capacity manual that was developed in India, we use a body width of 0.51 and a body depth of 0.35 meters. In addition, the Indo HCM also defines that more often than not, we do carry a luggage on our shoulder. So, we have to give an extra body depth of 0.52 meters. So, we have to give an extra body depth of about 0.15 meters, which in addition to the 0.35 meters, so that we can plan for any people, for an average person who is actually walking on the street with something on his or her shoulder. Okay. So, this is the average, these are the average values that can be used for designing any pedestrian facility. Next, how do we define a cyclist? Any person using physical power driven cycles, right, physical power driven. Now, there are electric cycles, electric bikes that are coming out. So, those do not fall in this realm. In this realm we only find bicycles, tricycles, and sometimes your vendor carts that have to be taken into consideration while you are designing for cycling. Okay. People who use cycles, three-wheeled rickshaws or four-wheeled carts, this should be carts, are included as cyclists. It is very important that we plan for cyclists as well. Sometimes it is noticed that walking, although it does not get a lot of importance while we are traveling, while we are looking at transportation, but it gets significant importance when we are looking at urban transportation. However, cycling is still not getting its due importance despite the high number of cyclists that are on our urban streets. So, it is very important to take into consideration cyclists along with people who walk into consideration while we design for NMT infrastructure. Now, similar to the body ellipse, there are also standard dimensions for any bicycles. Normal bicycle would be such, and we will give you the dimensions in the next couple of slides, but we are looking at the width or the length of the bicycle. We are also looking at the circumference or the diameter of the wheel. We are looking at the entire height and also the handles, the length of the handle. So, that is an important diameter that we have to look at along with the pedal width, pedal length as well. So, these all play an important role while we are planning for bicycles, because the handle is the one that will turn the bicycle in the direction. So, it has to have free maneuverability, it has to have space to maneuver. So, that dimension of the handle is also important. Now, in the Indian context, we also consider goods that will be transported along the on a bicycle. So, in order to consider the goods, standards look at either one piece of luggage or good on each side of the cycle. So, in this case it is shown as a cylinder, but it could be anything. However, it is restricted. We usually restrict them to a certain width. We do not encourage that very wide objects be carried on bicycles. Similarly, there are standard dimensions for cycle rickshaws as well as carts that are used to ferry vegetables. Now, here are all the dimensions that are given in one slide. These are as per IRC code 11 in 2015. You would see that an adult touring bike has a length, has a standard length of 1050 millimeters, whereas an adult touring bike with goods would still have the same length, but it would have a different width with rider, right. There will be so these are all both may be called riders. So, that is the only difference between when you are carrying goods versus when you are riding alone. When you are riding alone, you would the width to be considered is 750 meters. Similarly, different dimensions are given for passenger rickshaws, for good rickshaws and modified good rickshaws. Now, the next thing to consider when we are looking at NMT infrastructure are the traffic flow and the capacity of the facility that you are trying to build. Now, these basic terminology are all borrowed from vehicular traffic or motorized traffic, but they also apply in case of non-motorized transportation, right. So, the basic equation says that flow Q is a product of speed U and density K, right. So, that is the basic equation. Flow is equal to U times K. Now, the speed will vary as per the NMT mode, its characteristics and the built environment, right. So, we will look now further into what are the elements that affects the speed of pedestrians specifically before we get into bicycles, and then in the coming lecture we will explain these three diagrams in much more detail. So, what are the characteristics of pedestrians that affect speed? Now, why do you, first point is, why do you need to look into the speed of pedestrians while designing for pedestrian facilities? A, because you need to understand how many people can be accommodated along any facility, right. So, for example, if you have a sidewalk, you need to know how many people will a sidewalk accommodate per unit time, right. So, people are constantly moving or some people are standing. So, you have to take into consideration them as well. Some people may be standing, some people may be walking at a fast speed, some people may be walking at a slower speed. So, maybe on an average you can accommodate certain number of people per unit time. So, that people per unit time will give you actually the capacity of that facility. So, a given length of sidewalk, given width of sidewalk, you can accommodate n number of people per unit time. So, this n per unit time depends upon how quickly people move across that facility, right. Even if it is a crosswalk, for example, if it is a zebra crossing and people are trying to cross the road along the zebra crossing, you still need to know how fast the people can move across, what is the width of the road that they are crossing, in order for you to give the signal sufficient pedestrian walk time for them to cross the street. So, that is, those are the two basic primary reasons for which you need to know what are the factors that affect speed, right. The basic factors that affect speed are the age of the people that are on the facility, their gender. So, women tend to walk slower than the men. The trip purpose. So, if you are walking to go to office or walking to catch a train or walking to for some urgent purpose, then you would walk faster, whereas if you are shopping and walking and looking at different kind of stores, or you are walking with friends, you would be walking slower. Speed also depends on whether you are carrying any bags or not, and also whether if you are walking with a group with some group of people or not, right. These are different types of just pedestrians which are also factors that affect their speed. Now, if you look at the built environment characteristics. So, for example, where you are walking, right, that also affects your speed. So, if you are walking on a road that has some high gradient, right, if the road is very up and down, then your speed will vary. Walkway width. Now, if it is a very narrow sidewalk, right, then automatically you are aware, or you are very conscious of the fact that you are very close to the vehicles that are moving very fast on the road. So, you tend to be away, walking little bit away from the vehicles, and then tend to be very careful that you do not step onto the carriageway. So, that automatically kind of reduces your speed, and on top of it, if there are lot of people walking on that narrow footpath, then your speed gets reduced. The curb and the street furniture, right. So, now if you have lot of say for example, trees in between the sidewalk. Now, this is a very tricky situation. We do need trees for pedestrians to feel comfortable while they are walking, because they provide shade, and trees overall are a very essential part of the urban infrastructure, urban green infrastructure. But at the same time, if they are right in between your path of your walking path in the middle of the sidewalk, that causes some inconvenience to pedestrians, because now they have to walk around the tree, they have to bypass the tree, which kind of again reduces the speed. So, this factor not only reduces the speed, but it also causes a minor inconvenience to the pedestrians who might be wanting to walk the shortest distance between the 2 points and not go on a winding path. Well, again it depends on the purpose. If you are leisurely walking, then you would enjoy walking on winding paths, but if you have some other purpose, some urgent purpose, you would prefer that you walk fast. So, that is one of the things, and there are other things such as benches, and sometimes of course, the footpath is encroached upon, sometimes two-wheelers are parked on sidewalk, or sometimes even four-wheelers are parked on sidewalks or footpaths. So, those all cause great deal of inconvenience and also reduces the speed of pedestrians. Now, two-way friction is the other thing. If there is only a sidewalk on one side of the road and no footpath on the other side of the road, then all the people usually tend to walk on the side of the road that has footpath, and so you have a two-way traffic on one footpath, two-way pedestrian traffic, two-way pedestrian footfall on one side of the on the footpath. So, that again causes a lot of friction between pedestrians walking in both directions, and that friction reduces the speed. Last but not the least, of course, location effect. So, you are walking through an area that has many things to see, museums, good restaurants, good shops, then automatically your speed goes down, because you want to slow down and appreciate the environment through which you are walking, and so the speed reduces. So, this gives you an idea of what are the factors that the speed of a pedestrian depends upon. Now, based on the different types of pedestrians, there are some average values of speed that can be used, right. Based on age, you can say that the average speed at which people walk is usually 1.2 meters per second, right. The elderly walk a little bit slower, 1 meter per second. Now, when it comes to gender, men versus women, mean walking speed of men are about 81 meters per minute, whereas women walk a little bit slower of 76 meters per minute. When it comes to trip purpose, work trips, like we discussed already, generally are faster than leisure trips, and of course, if you have baggage, you are walking much slower than if you do not have a baggage. And similarly, so platooning effect is this: we often walk 2 or 3 friends together, and when we are walking together, our speed usually decreases. Okay. So, I mean, remember, we also should be planning for pedestrians with luggage. So, this is a typical example, say, so when you are planning for a pedestrian facility, for example, a platform on a railway station, you have to take into account the people who help us with the luggage and plan for them as well. Now, when it comes to built environment and its effect on speed, it has been seen that 10 units when there are 10 units of rise in every 100 units of length, right. So, when there is 10 units of rise in every 100 units of length on uphill grades, there is a 0.1 meter per second reduction in speed. So, when the gradient becomes steeper and steeper, for every 10 units of rise in 100 units of length, your speed reduces by 0.1 meter per second. No measurable effect on speed up to grades of 3%. So, up to 3% grade, you do not have much effect on speed, but once the grade is steeper than 3%, then you are kind of worried. Pedestrians tend to keep, okay, so this is what we were talking about, when there is a lot of street furniture and the curb is too close to the motorized vehicles, pedestrians tend to keep 0.3 to 0.45 meter lateral clearance from the curb line, right. So, we tend to walk a little bit away from the curb line, so that we are away from the motorized traffic. So, then the average space occupied by the pedestrians, and the average space occupied by the pedestrians are 72 to 79 meters square. So, one person on an average occupies anywhere, so maybe an average of 75 meters square on that footpath. So, given this lateral distance that we leave along the from the curb line and that space that we actually need to travel, there is an impact on speed. In case of two-way friction, speed and capacity decreases by 15% when the flow proportion is 10%. So, when there is a 90 to 10 directional split, so the 90% of the people are walking in one direction, 10% is walking on the other direction, there is already a reduction about 15% of the maximum speed at which they can walk on the sidewalk or footpath. At 50-50, capacity of a two-way facility is equal to a one-way sidewalk facility. So, if you have 50% of the people walking in one direction and 50% of the people walking in the other direction, it is as good as having the sidewalk a one-way sidewalk, right. That a two-way, the capacity of a two-way sidewalk is as good as one-way sidewalk. So, it reduces the speed, causes a reduction in the capacity as well. Now, here are some examples from various researches that have been done in different countries. So, you would see research from India, Iraq, Bangladesh, New Zealand, Canada, Sri Lanka, Thailand and Malaysia, as well as Israel. So, you would see that how the walking speeds differ based on weather, based on all these different conditions, right. So, you would see that it seems like in New Zealand the mean speed is the highest, right. The green color mean speed is the highest, almost just a little bit less than 90 meters per minute. If you look at India, different studies say different things. One study has said that speed is anywhere just above 70, maybe 75. The other study says it is less than 70, and let us see. So, it is around 70. So, I think under Indian conditions it is safe to say that the average speed of pedestrians is somewhere around 70 meters per minute, the mean speed, right. Then the speed varies based on whether you have luggage, whether you are older than 60 years old, older than 60, whether you are an adult or whether you are less than 15 years old, and whether you are a male or a female. So, this gives you an idea of the speed as a function of location / socio-cultural climatic effect, right, because all these countries have different climatic effects, different social cultural environment. So, you can see how speed varies depending upon that. Now, so a very important question is often asked, that how do you identify this variation in speed among different among two groups. Say for example, if you want to know whether actually the speed between men and women are different or not, or whether actually the speed between people who are carrying luggage versus people who are not is different or not, right. Many times the speeds are so close to each other that you feel that, well, there does not seem to be any significant difference, but statistically you are always required to see or check whether those speeds are different or not. So, what we usually use, statistical test that we usually use is an independent sample t-test. Okay. So, how do we do that? First, you need to identify the groups for which you are testing for the difference. For example, are you testing for difference between different ages of people, the speeds of different ages of people, or gender, or gradient. So, identify your groups. Next, you have to collect speed data for that group, right. Sample speed data for that group you need to collect for the two groups for which you are trying to find the statistically significant difference. In step 3, what you need to do is you need to calculate the sum of the differences as well as the square of the differences between the two groups. So, you will have a mean speed of you will have the speeds of one group, you will have the speeds of the other group. You have to calculate the sum of the differences. You have the difference of the speeds, you have to sum it up, and similarly you have to find out the summation of the squares of the differences. Then the t statistic, which is given by this equation, which I am sure very many of you would know. If you are not aware, it is available in any of the common statistical textbooks. So, you need to calculate what is called the t statistic, which is a modulus t, does not matter of whether it is positive or negative sign. So, it is a modulus, and it will be based on the number of samples for which you have collected the data. So, how many samples you collect, it depends upon that sample size. Then you calculate what is called the degrees of freedom, which is nothing but number of sample size minus 1, and finally you will have a table, a t statistic table, that will tell you what is the p value or the critical t value based on for standard p values, right. What is the t critical value for standard p values? Usually the p value that we use is 0.05, that means it is statistically significant at 95%. So, we usually look at 0.05, if nothing is specified you will look at 0.05 and you will find the some t critical value for your degrees of freedom. For example, if your degrees of freedom is 2, then your t critical value will be 4.3. So, now the value that you have calculated in the previous step t modulus, if that is less than your t critical value, then the inference would be that there is significant difference between the speeds of the two groups. Okay. So, that is how you find out whether there is significant difference between the two sets of groups which you are interested in finding out, and then you would know that okay, yes, there is significant difference, and hence we need to take into cognizance these significant different speeds and design for them accordingly. If there is no significant difference, then you can say that you have a pretty homogeneous group of people who are walking on that facility, and you can design the facility for an average or a mean speed of the entire walking population along that facility. Okay. So, let us quickly look at a simple example that will allow you to understand all the calculations. Now, say that you have collected the speeds of 10 different males, 10 different males and 10 different females. Okay. So, your aim is to find out whether these speeds are, whether the mean speeds between these two groups are statistically significantly different or not. Okay. So, the data collection was done, the groups were identified. Now, you had to calculate the t statistic. So, what you need to do first is to find out the differences between each, right, 72 minus 69 and so on and so forth, and then sum it up. Similarly, you need to find the squares of the differences and finally sum it up. Then you can use these formulas here and put up these values. So, this is summation of the differences by the sample size. So, it is 32 by the sample size is 10, right. Then the whole square root of square of the summations. So, that is 256 minus that is the summation 32 to the power 2 by n, that is 10, and this is n into n minus 1, 10 into 9. So, the answer would be 0.02004. Now, you need to know what is the t critical value for the degrees of freedom of 10 minus 1, 9, right, n is 10. So, 10 minus 1, 9. So, if you look at the table, the standard table that you have for 0.05 and degrees of freedom 10 or degrees of freedom 9, I am sorry, degrees of freedom 9, your t critical value is 2.262. So, what that means is your t value is less than your t critical, which means there is significant difference between the speeds of male and female. So, that tells you that if you are trying to plan a facility at that location, a footpath or whatever it may be, that there are significant different speeds of all the females and the males that walk on that road, and hence you have to take into account both of these groups when you are planning for this facility. I hope that is clear. That ends this lecture. Again, the references are given from which all the different exercises and the matter is taken for your further reading. In conclusion, what we looked at this, what we looked during this presentation or during this lecture were the understanding of who the pedestrian is and who a bicyclist is, for whom you are going to design the facility. So, what are their characteristics? And then we started looking at what are the pedestrian speed related factors that are affected, is affected by, or what are the factors that affect the speed of pedestrians. We looked at built environment factors, we looked at age, gender, and then finally, we looked at a statistical test that will allow you to understand whether there is a significant difference between the speeds of two groups that you are calculating for your site. Hopefully, that will be a very useful tool for you, and we look forward to having you in the next lecture module. Thank you.